Okay, in this next video, we're going to talk about the rational root theorem and how to use that with synthetic division to find all of your answers of a polynomial. We'll start off with a cubic function. We have f of x equals 8x cubed minus 18x squared minus x minus 10. Let's do our rational root theorem. And again, that's plus minus a fraction bar. The numerator of your fraction bar is all the factors of your constant term, so your 10. So 1, 2, 5, and 10. The denominator is going to be the factors of your coefficient of your leading degree, so the factors of 8. 1, 2, 4, and 8. Use this to develop a list. It's just division. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. 1 divided by 8 is 1/8. Do the exact same thing with your 2, 5, and 10, but don't repeat any values. So you're going to get 2. You're going to get 5, 5 halves, 5 fourths, 5 eighths. Go with your 10, you're going to get 10. And then 10 divided by 2 is going to be 5. 10 divided by 4 is 5 halves. 10 divided by 8 is going to be 5 fourths. So this completes our list. Okay, this is a list of possible answers to this cubic function. All of these obviously are not answers. They're possible rational answers. You would test in your calculator until you found the one that actually works. That means you're going to plug all of these in using your calculator function. So I'm going to go to my calculator. I'm going to go back to my y equals screen, clear out what's in there. I'm going to look at 8x cubed minus 18x squared minus x minus 10. I'm going to go to my table. I want to delete what's already in there, and I want to start asking it numbers from that list we just generated. So I'm going to start plugging in and see what I can find out. 1 and enter. That's not the one I want. -1 and enter. It's not the one I want. I'm going to go through my entire list until I find the one rational root that works. I'm going to test 5 halves because I believe 5 halves works. And 5 halves is my answer. How do I know that? It gave me a y value of 0. So 5 halves is a root or a 0 or a solution of this polynomial. I want to use 5 halves. So I'm going to come back to this screen. Using 5 halves means 5 halves is going to be used as my divider in my synthetic division process. So we put 5 halves in a little halfway box here. Outside here we're going to have all of our coefficients. 8, -18, -1, -10. And then we're going to follow through the process of synthetic division. Okay, this process, you're going to take a cubic function, third degree function. You're going to factor out one of the roots, leaving you with a second degree function, a quadratic function. So I'm going to show you the process. This is my cubic function. Synthetic says the first number always comes down. Always, always. And then the process is simply multiply 5 halves times 8. That gives me 20. Add straight down. -18 plus 20 is going to be 2. Repeat. 5 halves times 2 should give me 5. Add straight down. So you get 4. Repeat. 5 halves times 4 is going to give me 10. Add straight down to get a 0. Now notice I kind of halfway boxed off this last number because you're going to realize after doing a whole bunch of these that if your remainder is not a 0, then that means that this number you gave me here, this root, it's not a root. Didn't work. Okay? Well, you messed up some math in here somewhere, but this number should always be a 0 if you're telling me that 5 halves, or whatever you put in this box, is a 0 or a root of this polynomial. Okay? I got 0, so we're good. That means what's left? Well, again, we took a third degree function. We factored a root out, so I have a second degree function left. So these are my coefficients. 8x squared plus 2x plus 4 equals 0. This is my quadratic, ABC. Okay? So what I tell my kids to do is I want to graph this quadratic real quick because if it's a real quadratic, I want to find my answers, one of the easy methods. But if it's an imaginary quadratic, I know I have to use the formula. So let's graph this real quick. I'm going to go to my calculator, clear off the screen here, type in my quadratic, 8x squared plus 2x plus 4. Let's graph this. You can barely see here. Right here is the quadratic, right here. That means instantly we know this does not touch the x-axis, therefore my answers cannot be real, they have to be imaginary. So I have to go back to my other screen and work this out longhand by quadratic formula. So I'm going to go back to my screen. My formula, x equals negative b plus or minus radical b squared minus 4 times a times c all over 2 times a. X equals negative 2 plus or minus radical over 16. Notice I left that radical blank. I'm going to use what's inside this radical called the discriminants to help me describe to make sure I'm right with my process that I'm going through. Again, you could type this in the calculator or just do some simple math here. 2 squared is 4. A negative times a positive is still a negative. 4 times 4 is 16 times 8. 16 times 8. Let's do some math here on the side. 16 times 8. I'm going to get 128. So I get a negative 124 on the inside of my radical. Definitely going to be an imaginary number because my discriminant is a negative number, so very important. We need to now reduce this radical. Radical negative 124 means I got to figure out the highest perfect square that goes into a negative 124. So I'm trying to figure out my list of perfect squares. 1, 4, 9, 16, 25. I'm trying to see which one goes into there by doing simple division. So I'm going to say, and let me test it just to make sure real quick here, 124. 4 is my highest perfect square, so I'm going to have negative 1 times 4 times 31. So negative 1 times 2 squared times 31. My 2 squared comes outside because my square and my square root cancel each other. My negative 1, that's my imaginary, and my 31 has to stay on the inside. It's not a perfect square. Bring it back over here to have x equals negative 2 plus or minus 2i radical 31 over 16. This is your answer, but you have to reduce. Look at your whole numbers. 2, 2, and 16. 2, 2, and 16 are all divisible by 2, so it's going to be a negative 1 plus or minus 1i radical 31 all over 8. So those are my two imaginary solutions. So for this quadratic, we found two imaginary. For the cubic, I always like to write a sentence. This cubic function has one real rational root at x equals 5/2 and two imaginary at x equals negative 1 plus or minus I radical 31 over 8. So a cubic function can be solved using your rational root theorem, synthetic division, and your quadratic formula to find all of your actual answers.